Hello, my dear students and the rest of the learners. Welcome to part 33 of a 95-part series of tutorials in object-oriented programming series in C++, with our focus being on implementation of object-set classes using what we call the container class libraries. My name is MemeGM, or you can simply call me MLSwap. Many times we have to deal with many objects of a particular class. We may consider an array as some sort of basic or elementary container. However, for many abstract data types, or what we abbreviate as NDTs, some additional behavior is required. An abstract data type is a type whose behavior is completely different or defined by the user. For example, queue, stack, tree, and others. Even though many programmers can write or generate code by themselves, it is better to have a standard library. As this container will have different types of objects in different applications, the technique of template becomes more appropriate. Out of the many containers defined in the standard template library, some common ones are listed below. That is, classes contained in standard template library include the lists, the vector, the set, map, and the stack. We are also going to look at what we call the iterators. What are lists? A list is an enumeration of objects. In a list, length of the string can vary, unlike array. It can be accessed sequentially, both forward as well as in reverse direction. The commonly used functions with list include the empty, merge, popback, push front, size, end, remove, sort, erase, pop front, resize, swap, insert, pushback, reverse, and unique. The second is what we call vector. This is an abstract data type with the properties of both a list as well as an array. A vector is a varying length sequence of objects that we can access in objects randomly. It has a current capacity defined, and if required, this capacity can be increased. The commonly used functions with vector include empty, popback, size, end, pushback, size type, erase, reserve, swap, insert, resize. Let's now look at what we call set. This is an STL abstract data type that is generally a mathematical implementation idea of a set. A set is a varying length sequence of objects of type const key. Internal organization is such that lookup, insertion, or removal takes only log n efforts. Each element serves both as sort key and a value. The commonly used functions in set include count, find, lower bound, upper bound, empty, insert, max size, value comp, and key compare, size, value compare, erase, key type, swap, value type. The fourth one is called map. What is a map? A map supports elements of type pair. The pair consists of a key and an associated object. A map contains varying length of sequence of pairs, with the first element of each pair being the sort key and the second being the associated value. This sequence is represented in a way that permits lookup, insertion and removal of an arbitrary element with a number of operations proportional to the logarithm of the number of elements in the sequence, or what we call logarithmic time. Commonly used functions with map include begin, find, empty, insert, add, size, erase, swap. Use of maps for handling large size records is very useful as it assures log n performance. The fifth one is called stack. The template class describes an object that controls a varying length sequence of elements. The object allocates and frees storage for the sequence it controls. The operation is based on last in, first out philosophy, or what we call LIFO. The commonly used functions with stack include count, push, empty, pop, size. Let's now look at what we call iterators. Just as an array is referenced with an index, a container class defines a specific class object that we call an iterator. An iterator is like an index that helps us in referring elements of a different container class with a uniform interface. If the container is empty, the iterator may tell us that too. Depending on the type and nature of the container, the iterator will have different access-related properties. Some of them include forward, bidirectional, random access, input, output. The container classes, therefore, provide services such as insertion, deletion, searching, sorting, and also testing an item in order to determine whether it is a member of the collection. And with that, my dear students and the rest of the learners, we have come to the end of part 33 of this series, as well as the end of the topic, implementation of classes and objects. You can continue to part 34 of 95, in which we are going to commence on a new topic by the title Inheritance. And our attention for that presentation will be on the importance of inheritance and the inheritance topic. Congratulations, therefore, for learning part 3 of 95 on the container class libraries and the implementation of objects and the classes in object-oriented programming. You can access videos for the other parts in object-oriented programming series, as well as other computer or ICT videos by clicking or tapping on MediSwap ICT YouTube channel below this video. Remember to subscribe to the channel by tapping on subscribe button below this video in YouTube if it's not currently being subscribed. For any further correspondence, kindly write it to us through the email mdswap@gmail.com. Let's meet in part 34 of this series, and God bless.